Hi, in this video, I will show you how to tell different kinds of proportion problems, okay, such as hypothesis testing of two proportions or confidence interval of one proportion, etc. And the thing is, once you've mastered this skill for proportions, it's easily transferable to when we learn about the means. And with the proportion and mean all down, then when we move into more other kinds of inferences, you will be able to tell them apart easily once you've mastered this thing. So it's kind of important to get this part down. All right, so these are the four kinds of proportion problems that we've learned so far. CI of one proportion, CI of two proportions, or rather the difference in two proportions, hypothesis of one proportion, or hypothesis testing of two proportions. So you can see on here that you have two decisions to make, okay? The first decision you need to make is what kind of calculation are you gonna make? You're gonna make a confidence interval, or you're gonna make a p-value to figure hypothesis testing, right? And that's whether or not you're on the first row or you're on the second row. Okay. The second decision you have to make is whether you're on the first column or second column. Is that some sort of problem involving one proportion, or is it some sort of problem involving two proportions? Okay, so two decisions to make. So we'll do one at a time. And the first decision is how to tell CI from hypothesis testing. And here's the thing: if you have a CI problem, and then at the end, you'll be answer with a CI, with a confidence interval, okay? The confidence interval consists of a lower limit, this hand, a lower limit, and an upper limit, right? Or you can think of it differently, of having a point estimate in the middle, okay? And then plus or minus the margin of error, and then, point estimate middle plus or minus margin of error, and then the confidence interval lower and upper limit result from that, okay? All of those things, the point estimate in middle, the margin of error plus or minus, and then the lower limit and the upper limit, all of them will be numerical values. So if you think ahead of the answer, okay, you read the question carefully and you think ahead, imagine what the answer would look like. And if it looks like some sort of numerical answer, like you think, I think the answer is 15%, or maybe 75% plus minus something, okay? Or maybe it's something, I think it's between 10 and 17% maybe, okay? If you just imagine what the answer would be based on your gut feelings, and the answer comes out as some sort of numerical answer, that's a confidence interval problem, okay? So for example, if the question asks you to determine the range of proportion of students who don't have internet access at home, okay? And then you think about it, I think 33% of students don't have internet at home, or whatever number comes in your head, right? But hey, you're thinking of a number coming into your head, a numerical value, okay? It'll be some sort of point estimate, plus or minus margin of error gives you the lower limit and upper limit. So that makes it a CI problem. How about this next question? Usually about 40% of people in Costa Mesa go to some party on Saturday. During the coronavirus pandemic, what percent will go to some parties on Saturday? So pause and think a little bit about what would the answer be like. Okay, so hit pause. Okay, now resume. The answer would be, could be, you could be thinking in your head, probably people are all scared and only 10% go to parties. Or could be, I think people in Costa Mesa are pretty irresponsible. Okay, you let them home from work and home from school, they're all gonna go to parties. It's gonna be like 100%, baby. Either way, it doesn't really matter what the true answer is, right? as long as you imagine ahead of time that the correct answer will have some sort of numerical percent in it, that makes it a confidence interval question. Right? And that is to distinguish with a hypothesis testing question, because a hypothesis testing question doesn't arrive at a numerical value. Some of you don't get this, because when you actually do the problem, you have to compute a p-value, and then you have to do things. So you think the p-value is the final answer, but hey, wait a minute, the p-value is not the final answer, right? Remember, once you got the p-value, we still have to go do things like if p-value is less than alpha, reject H0. Then you have to write the verbal conclusion in context, okay? So no, the p-value is not the final answer. I'm talking about the actual final answer now, and that is, there is sufficient evidence that something is true. So hypothesis testing asks you to arrive at that final answer, which is to support or reject something, yeah? So that means, again, I want you to read the question carefully and imagine in your head what the answer would be like. If it sounds like the answer would be like, yes, it is, or no, it's not, then that makes it a hypothesis testing question, okay? Okay. Yes, it is. We have plenty of evidence to support that. Then I guess that makes it a hypothesis testing question. Or you may say, no, it's not. We have plenty of evidence to reject that. Then, yeah, I guess it's a hypothesis testing question. Yeah. Okay. And then, of course, there's also the other thing about, oh, well, sorry, we don't have enough evidence to support, or we don't have enough evidence to reject. Either way, it's asking whether to support or reject some statement. Then it's a hypothesis testing question. Yeah. Yes or no answer, hypothesis testing. Numerical answer with some percent or some proportion as a numerical value, confidence interval. Okay. So let's see some examples of hypothesis testing. First example, determine whether married adults are less likely to go back to college than unmarried adults. What do you think? Okay, in your head, if you're thinking, yeah, I think so, or if you're thinking, nah, I don't think so, either way, it doesn't matter, okay? You're just trying to think ahead and see what the answer sounds like. You're not actually trying to find the answer. You don't have any data here anyway, but you're thinking ahead on what the answer sounds like, and it sounds like a yes or no answer, okay? You're agreeing or not agreeing with some hypothesis. So that makes it a hypothesis testing question, okay? All right, next example. Do more than 8% of children get asthma? So hit pause and think about it. Okay, we're resuming. The answer to this is, no, don't think so. Or, yeah, I think so. I know plenty of children that get asthma. Okay, either way, that makes it a hypothesis testing question because you're saying yes or no to something. Okay, all right, I'd like to pause here. Well, no, don't pause. I'd like to mention something really quick here. Okay? The question has a percent in it. Okay, but your answer isn't the percent. You're not saying, you're not giving 12% as an answer. Okay, the boss asks, do more than 8% of children get asthma, then you should say yes or no. Okay, so think about it like a grammatical analysis of this question. What kind of question is it, and what kind of answer is it called for? Yes or no, then answer. That makes a hypothesis testing. Okay, if the answer calls for a numerical value, then it's confidence interval. Okay, it doesn't matter whether the question contains a numerical value. Okay. All right, so that was the first decision. The second decision is to tell the difference between one proportion and two proportions. And here's how you do it. You count the number of populations with unknown proportions in it. Okay, that would be how many proportions you have. Okay, now the good thing is if there's only one population, then that's the one. Okay, then that's automatically a one proportion problem. So for example, the whole question is about one kind of population such as US residents or doctors who are retired or cats that are black, or cars that are hybrid, whatever, then definitely that's just one population to deal with, and that's just one proportion. Okay, the complication comes in if you have two populations, but one of them, the proportion is known, so that doesn't count. That leaves just one proportion left. Okay, so if you see two populations, it gets complicated. Right? So let's take a look at this example and tell me how many unknown proportions do you see? Okay, how many populations do you see? And do they both have unknown proportions, or does one of them have a known proportion? Right, so hit pause and think about it, and we'll resume. All right, we're resuming. All right, the question asks, most family physicians are board certified in either family practice or internal medicine. Are there a higher percent of females among the family practice board certified or the internal medicine board certified? Okay, so there are two populations here. Okay, the family practice doctors and the internal medicine doctors. Okay, and the proportion we're looking at is proportion of females, right? Percent of females. So there are two populations here, family practice and internal medicine. Okay, so the family practice over here, do we know the proportion of females? Not in this problem, so that makes it one proportion. Okay. How about the internal medicine over here? Nope. So they're both unknown, so that makes it a two proportion problem. Okay. Now let's take a look at the next problem. Approximately 60% of US residents believe in angels. This is a survey done at Baylor University. Are residents of Canada more likely to believe in angels than residents of the US? What do you think? Okay, hit pause and tell me if it's a one proportion or two proportion problem. All right, we're resuming. There are two populations here. There are the US residents and there are the residents of Canada. Do we know the proportion in the US that believe in angels? Yes, we do. It's 60%. Baylor did it. So we don't count this number anymore. So that leaves just one proportion of residents of Canada. Okay, so that's a one proportion problem, even though two populations are mentioned in the question. Okay, so in other words, when you're trying to think of one or two proportion, think of it more like one or two unknown proportions. Yeah. So yeah, in summary, if you see two populations, then count how many unknown proportions there are. Okay, if one proportion has a known proportion, that leaves just one unknown, and that's a one proportion problem. Okay, if both populations have unknown proportions, it's a two proportion problem. Okay? So those are the two decisions you need to make: CI or hypothesis testing, and once you've made that decision, one or two proportions. So let's take a look at some examples. Children in Los Angeles County suffer asthma at the rate of approximately 9%. We sampled 200 children who live within 2 miles of the East LA interchange to see whether a higher percent have asthma. Okay? So the East LA interchange is a huge highway crossing system in East LA where several freeways come together. The 10 and the 101 and some more come together, and it's as big as the whole city itself. And with all the traffic going onto it, we suspect that the kids may have higher percent or not, I don't know. Okay. But let's hit pause and tell me whether or not this is a CI or hypothesis testing, and is it of one proportion or two proportions? So hit pause, think about it, and then resume. All right, we're resuming. First of all, is it CI or hypothesis testing? The answer is hypothesis testing because the question is whether a higher percent have asthma. And the answer is yes or no. Yeah, I think so. With all that pollution, you kidding me? Or you might say, you know what? I don't think so because they live, far enough. I mean, pollution got dissipated. So the rest of LA County is kind of polluted also. So I don't think so. Well, whatever your reasoning, either way, it's a yes or no question. I'm sorry. Yeah, it's a yes or no question and you give a yes or no answer. So that makes it hypothesis testing. Hypothesis testing of what? One or two populations. And the answer is one or two proportion. And the answer is one proportion. There are two populations here. LA County as a whole versus within 2 miles of the East LA interchange. Okay, there are two populations. But the number for LA County is known is 9%. So it doesn't count. That leaves just the East LA interchange kids. Okay, so that's a hypothesis testing of one proportion. All right, next example. What is the difference in percent of women having CPR certification and percent of men having CPR certification? So maybe there should be an extra word percent there. So percent of women having CPR certification and percent of men. All right, hit pause, think about it, and we'll resume. Okay, we're resuming. Is it hypothesis testing or CI, and is it of one or two proportions? And the answer is a CI question. Okay, what's the difference in percent of this versus that percent? Well, you take 2% and you subtract, you get a number. That makes a confidence interval, right? That number is going to be your point estimate, and then you do some sort of calculation to make the margin of error, and you end up with a lower limit and the upper limit. Okay, so that's your confidence interval. So this is a confidence interval problem of two proportions. There's women in CPR and men in CPR, and we don't know any of them. We don't know the proportion of women that have CPR certification, and we don't know the proportion of men that have CPR certification. Okay, so it's a two proportion confidence interval problem. Okay, next one. Approximately what percent of students at Hogwarts School of Magic and Wizardry come from Muggle families? You don't need to understand any of these words to answer the question of what kind of problem is this? Is it CI of one proportion, CI of one or CI of two proportion, hypothesis of one or of two? So hit pause and think about it and resume. Okay, we're resuming. Approximately what percent? So we give a percent, 10%. Yeah, that makes it a confidence interval. That's your point estimate with plus or minus margin of error. Okay. And of what? Oh, just one population, the population of students at Hogwarts School of Magic. Okay. The part about Muggle families, you don't need to understand any of these words that come from the Harry Potter series, but you don't need to know any of these words to see that the population is students at Hogwarts School. The proportion we're looking at is what proportion of it come from Muggle families. Okay. Okay, we're not creating a second proportion or population. We're just looking at the proportion inside this one population. So it's a one population problem, and it's a confidence interval problem, right? So next question. It goes backward. Anyway, does gender affect voters' opinion on climate change? We surveyed 200 men and 200 women to find out. So think about it, hit pause, think about it, and resume later. Okay, we're resuming. This one is a little bit tricky. Okay, gender affect something. So there are two genders, there's men and women, and it says survey 200 men and 200 women. Well, the 200 men is just a sample. The 200 women is also just a sample. So where are my populations? And don't be distracted by that. Okay, that was if you thought about that, then that was very nice. That was very astute of you to think about that. But don't let that distract you. The sample of 200 men that we are surveying, that's intended to represent all men anyway, right? That's why we survey things, okay? That's why we take samples, so they can represent the whole populations. So yeah, don't be distracted by the fact that these are just samples. We do deal with two populations here, the population of men and population of women, okay? And it consistent with the part at the beginning where they talk about gender. And we're sort of assuming that they're skipping over people that don't identify as either male or female. And then they deal with opinion on climate change. So it's not clear right there whether or not it should be a percent or some sort of mean. But you can think of it as like that exercise we did in class on whether or not people think that it concerns them a great deal. Okay, so what percent think it concerns them a great deal? Okay, so yeah, this could be a percent problem. And if it is a percent problem, then it's definitely two proportion problem. And it's a hypothesis testing because the answer is going to be either yes or no. Yes, gender affect, there is a difference between men and women, or no, gender doesn't affect it, men and women all think the same way. So it's a hypothesis testing of two proportions. All right, so that's how you do it, and I hope you will be able to use this information and eventually apply it to all the proportion problems you see, and later on all the mean problem you see, and then you can easily expand it from there. All right, thanks for watching. Bye.